One topic appearing more frequently on the exam is the proportional relationships, including the constant of proportionality. Essentially, in this case, which is a precursor to linear equations, proportional relationships always graph to a line. And the key is they're a line that must pass through the origin to be a proportional relationship. And they essentially denote the independent variable x is related to the dependent variable y by a constant of proportionality k, defined by y equals kx. That k represents a number. In this case, from the graph, I can quickly determine the k simply by rearranging the equation to y divided by x. And if you're familiar with slope from lines, this is very similar. It's not even the change in y and change in x. It's just simply the y divided by the x, because we always have a change relative to 0, which a proportional relationship must include the origin at 0, 0. So I can simply say my k equals, say, for example, any point 4 divided by the x coordinate, 2, is 4 divided by 2. My constant of proportionality here is 2. K equals 2 for that graph. Likewise, for this other graph, I might choose, say, this point. 21 is my y. 3 is my x corresponding to that. So my constant of proportionality is 21 divided by 3 equals 7 is my k value. K equals 7. Again, note we always pass through the origin. If for any reason we do not pass through the origin, say for example that line, it is not a proportional relationship. It is not passing through 0, 0. This one is. My constant of proportionality is, again, the y divided by the x, 40 divided by 8. In this case, k equals 5. We can also run into the concept with tables. K equals the y divided by the x. So in this case, that's the 6 divided by the 10. The constant of proportionality for this table is 0.6. For this table, it's 1 divided by 2. K is the y divided by the x, which is 1/2 in this case. And in this case, k equals the y divided by the x, which is 6 divided by 2. And note that is a constant. Even if I took this point, 15 divided by 5, I would get the same constant of proportionality, 3. And notice if the table continued, it would eventually pass through a point 0, 0. It has to pass through the origin if it is in fact a proportional relationship. In this case, I could use the constant of proportionality, knowing y equals kx, and then solving for k equals y divided by x. I can figure out from this table, it's 36 for my y divided by 9 for my x is 4. And I can fill in the missing squares in the table. 16 divided by 4 is 4. 5 times 4 would be 28 divided by 4 is 2. So once again, to summarize, proportional relationships are lines that are related by the equation y equals kx, where k is a constant that represents a number. These lines must pass through the origin, otherwise they are not proportional relationships. And we can always find that constant of proportionality, the k constant value, by dividing y by x.